Welcome students to Pradeep sir classes as PSC where logo can talk the physics. And students, we are in IIT Foundation course today actually, and this is the chapter is work, power, energy, and this is lecture number 3. And if you first in that class, then I suggest you to follow that particular two classes, that is 1 and 2. One is based on the basic, that is what is work, and the second is the numericals based on 1, and the third one is totally based on power. So again, this is IIT Foundation course, and today's goals is, and after seeing the lectures you are able to understand the definition of power. Power equal to force, this is vector, so force vector dot the velocity vector, that is it is the dot product, it is a dot product, so this is dot product, this is dot product. What is about vector, what is a scalar, and what is a scalar, what is vector, what is dot product, and we are able to know after completions of the class. So then the unit of power, kilowatt, megawatt, gigawatt, horsepower, microwatt, milliwatt, all the multiples of power. And the last one is the difference between watt and power. So today's class is all about power, and let's start with the simple definition. So students, what is power? What is power first of all, or the definition of power? So students, what is power? What is power? So you can say that the power of a source, the power spent by a source, the power spent by a source is the rate of doing work. So the power spent by source is the rate of doing work. How fast the particular body can do that particular work. Suppose students, this is a bus. This is a bus, and you have to lift your weight on the roof. So the first pulley, and this is the second pulley, this is the first one and this is the second one, and the two pulleys are one to lift that particular load within the roof. That you have to take into account. The load is same for that. The load is, there is the mass of this one is m and this one is m, so the load is mg. So the load is mg, g acts downward, so the load is m into g, and here it is also mg. And this pulley number 1, what is our pulley number 1? Okay, so this is the not like that, it's not a movie. Pulley number 1, so this number 1 and this pulley can take, for doing this work it takes 1 minute, and this pulley number 2, this takes 2 minutes to load this particular load within this and this second. So you can easily say that the power is, for the first one, the power is work done, that is mg, and this is, suppose this is the height of the bus, so it is mgh by time, and for the second one, this is T1, and for the second one it is mgh by T2, mgh by T2. So you can easily say that the P1 by P2, P1 by P2, and this is equal to this by this, then T2 goes into numerator if we divided this by this. So mg and mg cancel this one, and so this is T1. So you can easily say that the power is the reciprocal of time. So power P1 and this is P2, and this is equal to T2 by T1. Since T1 is 1 minute and T2 is 2 minutes, and the T2 is students, T2 is 2 minutes. So here T1 is less than T2. So T2 is greater than T2 is greater. That's why P1 is greater. So you can say that. So you can say that the power of this one, power of 1 is greater than power of 2, since T2 is greater than T1. So what is about power? The power spent by a source, that it consumes some energy with respect to time. This coolie can consume some energy with respect to time. That's why you can say that the power of this coolie, number 1, is always number 1. Okay. So this is power, that is the power spent by a source is the rate of doing work. So you can take a numerical example, and then we go to the first of all we want to discuss with the various unit of power. The various unit of power. So students, the expression is power equal to work done by time. So easily we can say that power, if it is in watt equal to 1 joule by 1 second. So watt equal to joule by second. If a source can spend 1 watt, the power spent by the source is 1 watt when he doing 1 joule of work in 1 second. If a person doing work of 1 joule in 1 second, then the power of the person, we can say that, then the power spent by it, then the power spent by the person is 1 watt. So a person doing work of 1 joule in 1 second, then the power spent by the person is 1 watt. So watt is this is the SI unit of this one, and we can write as this is the SI unit, and if we take into account the CGS unit, then we can say that in CGS power, unit of power in CGS, centimeter gram second system. So CGS system, in CGS system is arc by second. In place of joule, you can write arc by second. Okay, so this is the CGS unit and SI unit, and you can easily convert these to these ones, since 1 joule equal to 1 joule equal to 1 Newton into 1 meter. 1 Newton, so 1 Newton equal to 10 to the power of 5 dyne into 1 meter means 100 centimeter. So you can easily say that 5 and then 2, that is 10 to the power of 7 arc. So 1 joule equal to 10 to the power of 7, sorry, this is 10 to the power of 7. So 1 joule equal to 10 to the power of 7 arc. That's why we can say that in CGS, if you want to convert that particular unit of power in a particular unit to another unit, that is from SI to CGS unit, then you have to multiply 10 to the power of 7. Okay, so this is the power, and we can use, suppose take an example, students. Suppose your father take you to a school, and the school, it may be somehow, it may be a rainy day or something, and the school authority can say that the school is ended in 2 hours. So the guard, the security man say that it is ended within 2 hours, and you say that particular time, and you share that particular time with your car, with your bus driver, as 1 hour equal to 3600 second. So you say to your driver as 3.6 into 10 to the power of 3 seconds. So you say to your driver that you have to come 3.6 into 10 to the power 3 seconds, because for today's class it is ended at that particular time. So driver, is it possible to imagine for him or not? No, because this is a particular scientific method, and that particular driver cannot realize that particular one, and he can realize 1 hour easily. But if you say you have to come with 3.6 into 10 to the 3 seconds, then he is puzzled. What is about second? So this is also right and this is also right, but this unit is a predictable one, but this second is not predictable with a particular person. He cannot compare that particular time because he is not familiar with that particular time. So you have to say 1 hour. 1 hour. So when the power is much greater or very much less amount, then you have to apply a specific unit. Again, if you say this is 3600 second into 1000, and you can say this is 3.6 into 10 to the power of 6 millisecond, then it is more difficult. Millisecond, nanosecond, picosecond, femtosecond, it is more difficult, that particular one, because that particular second is used for a small time. Okay, so to measure a particular physical quantity, you have to use a specific unit that is comparable or that is predictable with a particular person. Okay, so for the period of time, it is a large, so it is, you can say that this I spend 1 day very well. And if it is in large, or the amount of the time is more greater, then you can say that I spent very well for that particular week or that particular year, and so on. Similarly, when the power is much greater, then you can say that the power is in horsepower. So it is a large unit, and that particular unit is used in mechanical engineering. Okay, so horsepower is a unit. Horsepower is also a unit that is used most frequently used for mechanical engineering. Okay, so 1 horsepower, and this is equal to 746 watt. It is nothing but the power of unit. When the power is much greater, 746 watt, then we can easily say that this is horsepower. Okay, And so what is power? The rate of doing work. The power spent by source is the rate of doing work, work done by time. So joule by second, arc by second, and these are the different unit. Similarly, when you used a multiplier, that is milliwatt, then 1 milliwatt equal to 10 to the power of minus 3 watt. It is less amount of power. 1 micro, that is U, and you can extend it this one like that. So this is microwatt equal to 10 to the power minus 6 watt, and milliwatt, microwave watt, and so on, and you can use a multiple of this one. So megawatt 10 to the power of 6, and gigawatt. Okay, and like the GB or MB or and so on, TB, 1 TB, terabyte, gigabyte, megabyte, and so on. So this is the unit of watt. Watt means it is a unit of power, and these are the different unit of power. So students, the next one is you have to establish a relationship between the power and the velocity and a force. So the power is equal to, prove that, we can say that, prove that power equal to, it is a dot product. It is a dot product. So power is a scalar one, scalar quantity, scalar quantity. What is the scalar, students? The quantity that possesses only magnitude. So power possesses only magnitude. But the force, you have to apply a particular force along a specific direction. So force is the magnitude plus direction. So this is a vector quantity. Vector. And the velocity. And you can simply think that when the displacement, when the distance is added with a particular direction, then it is displacement. So distance in a specific direction, then it is displacement. Displacement. Suppose A and B are the two positions, and A moves along this direction, along this direction, along this direction, but a particular one is moved from this to this one. So this is the shortest path. So distance with a specific direction, then it is displacement, and the rate of change of displacement is called velocity. So V equal to displacement by time, and the speed equal to distance by time. So these are the different cases. That's why we can take this one as vector, and when it is a vector quantity, then you have to use a arrow overhead. So you have to use an arrow overhead that specify that particular physical quantity is a vector one. So power, this is a scalar quantity, and force is a vector, and this is a vector, and when you multiply this one, so you have, in physics students, you cannot multiply a scalar and another scalar, and a vector and another vector. There are some specific rule. You can easily think that you go 3 meters along this direction and 3 meters along this direction. Then you can easily say that 3 plus 3, that is, we moved 6 meters. But if one moves along this direction, then he moves root over of 3 square plus 3 square, that is root over of 18, that is 3 root 2 meter along the specific direction, and it reach that particular one that you have already reached at that particular point. Okay, so when you have to multiply this one with that particular one, or this one with that particular one. So when we take a product of two scalar quantity, then what is the meaning of that particular one? Or when we multiply two vector quantity, then what is the meaning of that particular one? It is a specific significance. So don't go for that particular details. It is on the syllabus, that is 11th physics. So for that particular one you have to realize the particular formula, that is a vector dot b vector is equal to a b cos theta, where a and b are scalar. When there is an arrow over it, then it is a vector. So when we take dot product of two vector, then we get a scalar function, that is ab cos theta. Just memorize that particular one. Just memorize this one. So a vector dot b vector equal to ab cos theta. Okay. So p vector equal to a vector dot b vector. You have to prove that one. What is? That is power equal to, power is the dot product of the force as well as velocity. So power equal to force dot velocity. Okay. So power spent by person, power equal to, we know that this is work done by time. So if a person doing work of W in time t, then we can say that the power spent by the person. Okay. So write down the note. If a person doing some work, say W in t second, then power spent by him or her equal to work done by time. But students, we know that you have to memorize this one also, a dot b vector, and this is equal to ab sin cos theta, ab cos theta. Okay. So is it a clear view or not? Still okay. So this is fine. Power equal to work done by time. So work done equal to, students, we know that force and displacement. So F dot S. Go to the first lecture and where I explain the component of displacement along force and the force component of force along S, and we can write that a vector dot this vector, since work is also a scalar, that's why you can write F dot S. And within the IIT foundation course, I think there will be a little bit of vector or scalar chapters related, all the concepts related with vector I explain within a particular chapter. Okay, then it will be better for you. So F dot S, power equal to F dot S, or we can write as F dot S, and this one is Fs cos theta. Okay, Fs cos theta by t, or Fs cos theta means F dot S by t or S by t, that is V, velocity vector. So power equal to these and these. Okay, here it is a t. So power equal to F vector dot V vector. And now the next part is what is the power, what is the derivations of these related, how are the units of power it is related, and the interconversions of the different unit system, and the next conclusion, that is what is the difference between work and power. So students, you can write that one with a different, you can easily write what is the difference from the lecture number 1 and the lecture number 3. for today's lecture number 3. So this is work and this is power. So power, work is, what is work? When a force applied on a body that can displaces the body along the direction of force, that then we can say that this is work. So work is defined as the force, applied force can displaces the body along the direction of force. This is work. And what is? So the first one is work equal to F dot S, but the power equal to F dot V, because power equal to work done by time by this one is here. So this is the first difference, that work is said to be done when a particular force can displaces a body along the direction of force. And the second one is, it is the rate of doing work. This is called power. And the second one is, and it is also a scalar, this is also a scalar, so it is not a difference, but the unit of this one is work. Unit of work is joule, but unit of power is watt. But the unit of power is watt. So the two are different physical quantity. Okay, so power, we can say that work doesn't depend upon, work doesn't depend on time. But the third one is power depends on time, because it is the rate of doing work. So these are the difference, students. And I think what is work, what are the different numericals related with it, this is lecture number 1. You can realize the definition of work as well as the different unit used in it, and the numericals, and then power, and then numericals again, and then explain energy, and then conservation of energy, and the different numericals related with this one, and what are the different sources of energy. That is the next and final lecture, and then the conservation of energy. Okay, and so wait for all the exciting lectures are conducted day by day. And if you think that it is a conceptual channel, then subscribe and share with your friends. And last of all, I want to say, continue your study and take for that particular time we are going through, you can choose an online basis. Okay, thank you and good night.